Hello, Math 8 students. This is Utah Middle School Math Project 2.2e, More Representations of a Linear Context. To get started, we do have an equation that we need to write given this story. It's a little quick poll. You found a summer job working for a landscaping company. They have agreed to pay you $20 for the day, plus an additional $5 for each lawn that you mow that day. So you need to write an equation to represent that. Go ahead and pause the recording as you write your own equation now. Okay, and students in class have written equations, and a lot of them are pretty close. A lot of them have some right ideas, but there is only one correct one. So everyone's going to be taking some notes on this, as we should already be doing for a warm-up anyway. We do it on paper first. Let's add to the notes that we surely have already taken. It is so much easier to write an equation if I have some way to organize the information, like a table. So what are the things that are changing within this situation? What are the labels going to be? Aaliyah. Yeah, one can be money. What's the other one going to be? Go ahead, Aaliyah. Lawns mowed, exactly. Now, there's going to be some discussion about which goes where. If we're going to do lawns mowed, and we're going to do money, which one goes where? Is the money going to go here or here? Is the lawn's going to go here or here? You guys need to decide that, because that does have an impact. What are your thoughts? Check in with your tables real quick. What are your thoughts? What's going to go where? Okay, and just real quick, what are your thoughts? Which one's going to go in the first column? Weston? Yeah. Yeah, and we can go back to science for this. I know you guys have talked about dependent and independent. We're going to also talk about dependent and independent in the next unit, actually. Which one is influencing the other? Is the number of lawns influencing how much money you make? Or is the money you make influencing the lawns? The lawns are what determine how much money you make, right? And so since that is our independent variable, it goes in the first column. The lawns are affecting the money. Okay, with that being said, what are some number of lawns that I could mow? I could just mow 0 lawns. Could mow 1, could mow 2, etc. And now if I mow 0 lawns, how much money am I going to get paid? Weston, are you sure? Read the story again. Yeah. You don't have to do anything. You just have to show up to work. And when you show up to work, what are you getting paid? $20. I know, it would be nice. But if you actually do some work, then you get paid even more. So what if you mow 1 lawn? How much are you going to get paid? $25. What if you mow 2 lawns? How much are you going to get paid? $30. What is changing and how much is it changing? Is this changing by 20 each time? No, it's changing by 5 each time. So that is enough that we should be able to write our equation. We know where we're starting. We know how much money we're going to make no matter what. We also know what the rate of change is, or what our slope is. How much is it changing? 5. And here's some other clues. Eyes on the screen. If I mow 1 lawn, how much am I making just because I mowed that lawn? $5. But is that all I'm going home with? What else am I going home with? The extra 20. How much money am I going to make just for mowing? Let's skip down to 3 lawns. Just for mowing 3 lawns. Don't worry about anything else. Just for mowing those lawns, how much am I making? 15. How are you getting that information in your head so quickly? Kale. Counting by 5s. Okay, so if I'm counting by 5s, that means I've counted by 5s 3 times here. Or in other words, 3 times 5. But that's just 15. What else am I making? The extra 20. And that gives us a clue as to what our equation is going to be. So if I keep this as x, because I like x's and y's. If I keep this as x, what am I doing with that x value? However many lawns I've mowed, I multiply that by 5 because that's how many dollars I make. But that's not all. What else am I getting paid? Yeah, an extra 20. That's right. Yeah, thank you. And that is equal to the amount of money. This is what you should have written, and a lot of you guys were close. Yes, and so is writing it the opposite way, is that correct? So what is it that's changing? That is our rate of change, and that needs to be multiplied by the x. It makes sense when you really think about it, right? Because we always have to add in that extra 20 at the end, because that's how much money we made just for showing up to work. So here is what we're working on today. All right, so in this lesson, more representations of a linear context. What I want us to do is we're going to tie in all of the different ways that we can represent a linear relationship, and that we're going to kind of build through them, increasing our fluency. So let's just kind of flip through this packet and you can see what we've got going on. The first one is about the state fair, and you can see there's a section here for context. That just means story. What does context mean again? Story. So we've got a story, and then you can see we have a place where we can write an equation. We have a place for a graph, we have a place for a table, and all of those are blank. We have to fill those in. Then I'm going to ask some questions later on, okay? But that's the general format. Let's look at the next problem. What do you see for the next problem? What information am I giving you in the next problem? Mappa. Yeah, this time I'm giving you the table. So you have to take the information from the table, make a graph, that's easy. Make an equation, that's easy. The hardest part is now you also have to write a story. And it's not that hard when you really start thinking about it, but you do have to write the story. Next one, look at number 3. What information am I giving you this time? Ariel. Yeah, now it's the graph and we've got to fill in all the missing pieces. And the last one, I'm giving you the equation. Can you look at an equation and still get enough information to make a table, a graph, and a story? By the end of this lesson, that is the ultimate goal, right? Okay. So let's go back to number 1. You and your friends go to the state fair, and it costs $6 to get into the fair and $2 each time you go on a ride. We need to consider that relationship between friends and the number, or sorry, not friends, between the number of rides and the total cost. Anyone feel like right now they could probably write the equation? Okay, 1 or 2 of you, that's good. Write it down in pencil, that way if you need to erase it, then you can. Give it a try. If you think you're ready to write the equation, give it a try. I like to save the equation for last, but challenge yourself, see if you're ready for it. Let's do the table first. Yes, we're still going to use the variables x and y. So I'm going to start by labeling that, but we have a story, and that means our table shouldn't just have x and y labels. It should have labels that relate to the story. So what are the 2 things that we're looking at? It says the relationship between the number of rides and the total cost. So again, we need to figure out which one goes in the first column. Is it rides or cost that go in the first column? Check in with your tables. What do you think? Okay, who wants to share their thoughts? All right, Michael. Cost goes first? Oh, those were supposed to be separated. Okay, you said costs in the first and rides in the second. Who agrees? Okay, we've got one other table that agrees. And the other 2 tables, what do you guys think? Aaliyah. All right, who else agrees with its rides on the left and cost? Okay, and the other tables. Decide then, who's right? Which one is influencing the other? Are the rides influencing the cost, or is the cost influencing the rides? Oh, what is it? What is it? Yeah, the rides are influencing how much it costs, right? All right. Okay, Weston, let's hear it.
So the reason why it rides on the x-axis is because they're switching between rides every time.
Yes. And the number of rides is going to change, and that's going to influence the cost, right? Okay, great job, great discussion. Now let's start filling it in. What are some number of rides that we could ride? How many rides could I ride? I could ride 4. What else? Sure. Could we ride 0? Just wondering. Okay. Are we going to have very much fun? Probably not, but is it a possibility? Yeah. Could we ride 1 ride? Could we ride 2 rides? And then if you want, after that, if you want to get silly and say 600, sure, that's fine. That's great. You're going to learn more by skipping around than by continuing to go in order. So let's jump around to 5. And then let's jump to 10. Or 600 if you want, I don't care. Okay, and that's what I love, is when you choose something different, then it makes your brain grow more, because you have to try and figure out what's going to go there. What are the costs? So I ride 0 rides. How much am I paying to do that? Michael? $6. It's not $0, right? We've gotten so used to, back in our proportional unit and stuff, saying, oh, if it's 0, it's 0. But it costs $6 just to get into the fair. Not that we want to do that, but it does cost $6 if all we do is go in there. And it says $2 each time I go on a ride. So that means one ride is going to cost $2, right? Yes, Aaliyah? Great. Exactly. Yes, the ride itself costs $2, but the total cost isn't 2. The ride itself just costs $2, which means now I'm paying not $2, but $8. And why am I paying the extra $2? Because I rode a ride. All right, gonna ride another ride. So, how much more am I gonna have to pay now? That's another $2, right? For a grand total of 10. And if I ride another ride, that's gonna be another $2 for a grand total of 12. But what's happening here? How many rides am I going on now? 5. I haven't just increased it by 1 ride, I've increased it by 2. So how much is this going to increase, Weston? Mm-hmm. Good. So that means how much am I increasing it by total? I'm increasing it by 4, because you recognize that we skipped the 4. So that's going to increase an extra amount. And now I've skipped 5 here. We went from 5 rides to 10 rides. You maybe chose something else. Let's think about how much is that going to change the cost. Quick discussion at your table with whatever you put in there. How much is that going to change? How much more is it going to cost based on what you put in there? Okay. How much is this going to cost me? How much more? I'm going on 5 extra rides. How much more is it going to cost, Micaiah? $10 extra. So my grand total is $26. Okay. I think we're ready for the graph. X-axis is measuring rides. So I'm not just going to label it with X, I'm also going to label it as rides. This is the Y-axis, but I'm not just going to give it the label of Y, I'm going to give it the label of cost. Now it's time to scale it. What am I going to count by? Let's focus on the rides first. Does it make sense to count by halves? Am I going to be able to ride half of a ride? No. So the X-axis, it makes sense to count by ones. And yes, I'm counting by ones even if I'm lazy and skip certain marks. I'm skipping it knowing that it would be a count of 3 and 5. Will you discuss at your tables, what do we want to scale the Y-axis by? What do I want to count by in the cost? Talk with your tables real quick. Ready, set, go. All right, what did you decide? What do I want to count on the Y-axis? Ariel. Yeah, I think 2s is going to work nicely. Now, you may have chosen 4s, you may have chosen something else. All of that's fine. Just for the sake of consistency, though, I'm going to count by 2s. So that means this is 2, 4, 6. And if you want to do something different, that's great. You can do something different. Whatever it is that you decided to count by, just make sure you plot your points correctly. If I'm going on 0 rides, it still is going to cost $6. So over 0 and up 6. Over 1 and up 8. Over 2 and up 10. Over 3 up 12. Over 5 up 16. Over 10 and up 26. And we're not surprised because the name of the lesson is literally linear context, more representations of linear. So are we surprised that this is making a nice, straight, beautiful line? Yeah, not really. So there's my line. We've got 2 representations. Now we just need to finish up with our equation. Now, those of you who were not able to write the equation before, see if you can give it a try now. Those of you who wrote it before, you can maybe be a help to those at your table. I see some hands. Let's give it just a little bit more think time. Okay. Who would like to share their equation with the class? Michael, give it a try. Great. Y is equal to 2x plus 6. Let's see if that makes sense. Each ride. How much am I paying just for the rides? $2. But the rides are changing, right? After I pay for the rides, what else did I already have to pay for? The extra $6 to enter the park. That is correct. Great job. And now, if you have been paying any attention at all, you'll notice I've been color coding. This lower section here is also a time to color code. We have this section on the left that's called rate of change. And rate of change says below, highlight using red. I used red consistently whenever I was talking about the rate of change. So, what is the rate of change? How much is it changing? Again, look at the cost. Do you see how it's changing? How much is it changing? Aaliyah. 2. Why is it changing by 2? Why is this going up by 2? Mappa. Yeah, because the rides are increasing by 1. So watch what I'm going to write down here. 2 for every 1. But what happened when I started skipping? It's no longer changing by 2. Now it's changing by 4. But why did it change by 4? Because it changed by 2, exactly. And 2 divided by 1, isn't that the same as 4 divided by 2? Or even here. This increased by 10 rides, or sorry, $10. Why? Because that increased by 5 rides. And what do all of those simplify to be? 2. So what is the rate of change? The rate of change is 2 over 1, or simply 2. But what does it represent? Mappa already said. In the story, it actually represents the $2 per ride. We're going to continue highlighting using red. I've done a lot of red here in the table. There's no red in the graph. So where am I going to look and see the rate of change in a graph? How can I see the rate of change in a graph? Mappa? It's the slope. So let's find the slope. What's the slope of this line? What is the slope of this line? Kale? It is 2. Good. I'm so glad you guys didn't fall for it. I might be tempted to say the slope is only 1 because I'm going only up 1 and over 1. And what would you say to that? Yeah. What are we counting by? We're counting by 2. So when I'm going up just 1, I'm really going up 2. From 10 to 12 is an increase of 2. Going over from 2 to 3 is a run of 1. So the slope, yeah, the slope is the rate of change. Exactly. And I've shown that in red on my graph. I showed that in the graph, it's the slope. In the story, I didn't do it in the story yet. In the story, where do I see that 2? $2 each time I go on a ride. So what does it mean in a story? In a story, it's how it changes. Makes sense because it's the rate of change. And the last one in the equation. Where did you see the red in the equation? It's a 2, right? So where am I seeing it? It's what's multiplied by the x. Okay. Okay, next. Y-intercept. Y-intercept, what is it? Where is it crossing the y-axis? Right there. That number is 6. But even better, even more precise, and even more important is it's 6 when the x value is 0. That's what makes it be on the y-axis. So I like writing it as a pair of coordinates as 0, 6. What does it actually represent? That 6. What does it represent in the story? Aaliyah. Yeah, the cost to get in. It's our entry fee. And where do I see it? In the table, graph, story, and the equation. We're going to highlight it using green, which I've already done most of the time. Where do I see it in the table? Did you notice that I did that in green? Yeah, I'm going to circle the whole thing in green, or if you have a highlighter, you can just highlight over that. It's 6 because the rides are 0. Where do I see it on the graph? It's literally where it crosses the y-axis. Did you notice that I already did that one in green? Cost $6 to get into the fair. That's in green. And what does that mean for the equation? It's what we have to add on at the end. Or really, I guess we're adding it on in the beginning, right? Okay. Easy enough. Put it all together. These are some deep thinking questions. How would you change the context so that the relationship between the total cost and the number of rides can be modeled by the equation y is equal to 2x? What if I didn't want the equation to be y equals 2x plus 6? What if I wanted it to just be y equals 2x? How does that change the story? Kale. Or we could just say there's no entry fee. But if you want to be sneaky and sneak in, then that's fine. Sneak in, skip the entry fee. What if I wanted the equation to be y equals 6? Not y equals 2x plus 6, but y equals 6. What does that do to the story? Weston. Does it mean that we're only riding 6 rides? No. What does it mean, Micaiah? Yeah, you pay the entry fee. Only, and again, I want to think of it a little bit differently. It's not that we just sat there on a bench, but we paid the entry fee. No cost per ride. We can ride as many rides as we want. We just have to pay to get in. Yeah, season pass. Lagoon. That's how it is at Lagoon, right? Okay. Next problem, again, you're going to notice on this one, there's no context, no equation, no graph, but there is a table. The table does give us labels, so we can look at the labels, and that gives us some ideas about a story. But let's start simple. How's it changing? What's happening in this table? What do I see? Go ahead and get us started, Weston. Yep, but how is the table changing? Close. 7 plus something is 9. 7 plus 2, not going up by 3, but up by 2. And why did it go up by 2? Because what happened over here? The hours increased by 1. Hour increased by 1, so what happened over here to the cost? Increased by 2. Notice that I'm doing that in red. Gonna do the highlighting now while I'm doing the problem to save me some time later. Okay, we can see the rate of change. Let's start putting the information into a graph. That'll be the quickest and easiest one. In the graph, we've got our x-axis where we're measuring hours. We have our y-axis where I'm measuring the cost in dollars. Let's scale it. I think just, again, just like before, counting by ones makes sense here. is counting by twos going to be as nice here on this one? No. None of them will be on crosshair points because none of these are even. So we have some options. We can count by ones. We don't see very much information in the graph. We can count by any other number. I like to have some crosshair points, so even though we're not going to see much, let's just go ahead and count by ones. Which means I'm not going to see a whole lot here on the bottom part of the graph because the first information I have is at 0 hours, it's going to cost $7. Oops, 7, 8, 9, 10. I'm going to start putting that information on my graph. Over 0 and up, 7. Over 1 and up, 9. Over 2 and up, 11. 3 and up, 13. And again, I am seeing this beautiful straight line. Such a nice pattern. Hey, while I'm at it, what's the slope of this line? What's the rise? What's the run? MAPA. Yeah, up 2 over 1. And we are counting by 1, so when I'm going from 11 to 13, it's increasing by 2 over by 1. I think that means, do you think you're ready to write the equation? Yeah. What do we have to pay no matter what? What do we have to pay? $7. What's changing though? It's increasing by 2. What is the equation going to be? Great. Weston, give it a try. Oh, it's not 7x plus 2. Where's the 7? 7 is how much I have to pay no matter what. The 7 isn't changing. It's the 2 that's changing. Ariel, give it a try. Yeah, 2x plus 7. Again, the x, each time the x value changes, that means that the y value is changing by 2. But no matter what, we still have to pay that extra $7. So let's make a story that matches this. Kind of similar to this, but let's make it more interesting. Let's just not go to a fair and now it costs $7. Let's make it more interesting. What are some things that I might have to pay $7 for just to get in? But then it's going to change every hour. Kale. Say that again? The pool. Okay, so you have to pay $7 to get into the pool, and then they kind of charge you an hourly rate based on how long you're going to be there? Yeah. Weston. Yeah, parking garage. I think that's great. When you enter a parking garage, you have to pay just to get in, right? And then you have to pay for however long you're going to be there. Self-storage, yeah. Pay for the actual rental, and then you have to pay to store some things. I had another class that came up with you'd pay $7 to join the mafia, and $2 every hour they keep you alive. So, you know, there's that. You can get creative and you can get interesting stories here, but let's just go. I like the parking garage one. That one's creative. You pay $7 in a parking garage, or $7 to enter a parking garage. And we pay an extra $2 every hour. That works. And we've already done our highlighting. What is the rate of change in this story? How much is it changing? Kale? 2, or in other words, that would be 2 over 1. What does that mean for the story? We've written our story now. What does that 2 actually mean in the story? Alexis, what does the 2 mean in the story? Yeah, $2 every hour. And again, I've highlighted in the graph, it's our slope, highlighted in the table, our rate of change, highlighted in the equation, and in the story. And what about the y-intercept? What is the y-intercept in the story? Let's go, Daisha. What's the y-intercept in the story? Look at your graph. Where's it crossing the y-axis? At the 7. Yeah. It is 7, and remember, I like that even better if we write it as 0, 7, the pair of coordinates. What does it represent? What does that 7 mean in our story? Caleb, what does that 7 mean in our story? Yeah, it's an entry fee again, right? $7 just to get in. And again, I've already highlighted in all those places. So if you've kept up on the highlighting with me, then you've already done all of that stuff. Trying to make some connections with color. And now, part A. How would your context change if the rate of change was 3? How is our story going to change? Instead of a rate of change of 2, now it's 3. What does that do to the story? Good. Ariel. Yeah. So our slope is also going to change to 3. That means it's going to be steeper. And I didn't hear, did you say how it's going to change in the story? What is it going to do in the story? Say it one more time for me. Yeah, it's $3 every hour now, instead of $2 per hour. Okay, that's all that we have time for in this video. This lesson is going to continue in a part 2 video. So that's it for now. Thanks for watching.